Very similar. Paying attention, please. It says Julie's home. Julie's home is 3 blocks north and 5 blocks west of her school. So if I put her school here, her home is 3 blocks north. 1, 2, 3 north, and then 5 west. 1, 2, 3, 4, 5. Now, would that be the only way that Julie could get from home to school? Or does she probably have other blocks she could walk? Or is there just one road weirdly like that around town? No. So we do have to connect it and make a pathway system for her. Now, if you're like, there's no places like that, go to Little Town, Saskatchewan. They all look like that. They're perfect little block systems. All over. Where I grew up, you walk one way from one end to the other town. It's a straight line, and the other way. You yield on the crossings, and you go straight through on the straights, and you know that. The north-south surge, you don't yield, and the east-west, you yield, and guess what? There's no yield signs. But as a person in that town, you know it. So if you were like an intruder, you're going to get crushed. You know you need to yield east-west, and you can drive straight. That's north-south, and there's no yield sign. Okay. Didn't see a traffic light until I went to Medicine Hat. Okay. We had one stop sign when you entered town. All right. I think they may have invested in yield signs now, but it was just a known fact. All right. So it says, how many routes can Julie take from home to school traveling east or south or east? She has to go either down or over. If she could go back, she would circle. She could have infinity pathways. She could be crazy. She's like, I don't want to go. You know? Can you put your pencils down? I'm going to show you using actually pathway systems how we can count them. We're not doing that in this curriculum because this curriculum is perms and cons, like permutations and combinations. So that's what we're going to use. But I'm going to show you that I can count the pathways and it results in the same answer, so you don't just believe me. That that's how we can get the answer. Okay? Everyone's not writing this. You do not need to do it this way. Okay. We can only either head east or south. That's the only options we have, right? So one path, we could go all east, down south, the one I drew. Or I can go 1 south, this many, 5 east, 2 souths. Or I could go 2 oh my gosh, I'm struggling. 2 souths, 5 east, 1 south. But ultimately, I'm going to have to do 3 souths and 5 easts, correct, at some point? Because I could go east, south, east, south, east, south, east, east. Still went 5 easts, 3 souths, correct? Or I could go south, 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 5 easts. Still went 3 souths, 5 easts. Is that true? No matter what, to get from one to the other, you're going to have to do 3 downs and 5 overs. Yeah? So I'm going to show you how we could count the pathways as long as this is not how we're going to do it, but I'm just proving the point that the answer will still be the same. So this would be 1, 1, 1, 1, 1. They should get the dots. There's one pathway to get me here. I could walk to it. I could walk to this one. I could walk to that one. I could walk to this one. I could walk to that one. Correct? Let me take out the ones that I put weirdly in the middle here. Then I have one pathway could get here, here, and here because I could just walk to those. Right? That'd be one path. Now I start summing up my paths. So to get to this path, I have one path coming in and one path coming in. So that's 2 total paths. Correct? Here I have to get to this one. I now have 2 paths coming in, 1. So that's 3 total paths. And to get to this one, I have 3 coming in, 1 coming in, so that's 4 total paths. 4 and 1, that's 5 total paths. 5 and 1, that's 6. Then here I have 1 and 2, so that's 3. 3 and 3, that's 6. 6 and 4, it's 10. 10 and 5 is 15. 15 and 6 is a total of 21. Then I have 1 and 3 paths, so 4. 4 and 6 paths, 10. 10 and 10 paths coming into here, 20. 20 and 15, 35.
Grade 12, last name A to D.
35, 56.
Thank you.
If you're A to D, can you wait 2 seconds? And by 2 seconds, I mean like 1 minute. You'll still make it there. because I just want to show you how we do it with permits and comps, okay? So we agreed that that's 56 total pathways, yes? We also agreed that I have to do 3 souths and 5 easts, right? Instead of saying south and east, I'm going to say 3 downs and 1, 2, 3, 4, 5 rights, correct? So I can treat this like the word der. How would I rearrange der? No restrictions. What would have to go on the bottom? 3 factorial for the D's. What else? 5 factorial for the R's. What will go on the top? No restrictions. How many letters are there? 8. So it would be 8 times 7 times 6, 5, 4, 3, 2, 1. Type that in. What's the answer? Oh my goodness, it's the same. Shocking, I know. $56. If you were called A to B, you can go. All right. Guys, this one has a connector, correct? So let's pay attention. This one says, a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. Determine the number of routes. So now we have one little pathway from the bus station to the connector, which I put a really big dot in the connector because I'll show you why in a second. So I go like this, really huge dot. Because a really huge dot might represent what are we going to do? What does a dot represent in mathematics? Multiplication. Yeah? So here's our little pathway, and here's a second little pathway. So I'm going to figure out this little pathway, I'm going to figure out this little pathway, and what might I do with those two? Multiply them. So I put a really large dot in between. And we multiply because we need these ones and these ones. Okay, let's pay attention. So if I do this pathway, I have now a down, 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 down. Yes? And a right, right, right. So for this pathway, I have right? True? Correct? And let's look at this pathway. For this one, I have a down, down, right, right, right. So for this one, I have a True? So let's rearrange those words. How many ways could I get? So this one's going to have a what in the denominator? 4 factorial for the D's and a 3 factorial for the R's. And then the top didn't say, if it said I had to go down first, then that's it. Then I would have 4 factorial, or 4, 6, 5, 4, 3, 2, 1. Do you know what I mean? If it said I had to go down first, then I would do my fundamental accounting principle. I had 4, then 6, 5, 4, 3, 2, 1, right? But it didn't say anything about having to go down first. So I can just go what up here? 7 factorial. And then this one, I have a 2 factorial and a 3 factorial. And then on the top, I'm going to have 5 factorial. Now I need to do these and these pathways, so I'm going to multiply. Do you think they'll have one where they have an addition in the middle, in case you mess up? Do you think they're going to have that answer? So I put a ginormous multiplication dot in the middle, so that at least if I forget and is multiply, perhaps this giant dot will remind me to multiply them. You know what I'm saying? Okay. So question 7 from the homework, which I didn't make you do, is this. Go do it. So flip to it after your homework question 7.